Hello guys. So in this session, we will talk about we will see on the example of the estimating activity duration. So previously we've talked about the rules of estimating and the steps of developing a precedence diagram or project scheduling. So in this video, we will discuss about uh, we will take a look on example on how to estimate activity duration. So subcontractors usually are in the best position. In the best position is your subcontractor to give duration. Usually we consult subcontractors. If the project is being done in-house, you have your own site foreman, you own your labor, a general worker, and your skilled workers. So you can consult with your site foreman and your skilled workers on duration of each activity. Let's say you ask the person, so how many days can you finish per you finish a wall of certain heights and certain thickness. So how many days for erecting up this scaffolding should it be needed? How many days to fabricate the formwork, for example. So you can consult with your uh, site foreman, skill worker, or your best is to consult your subcontractors. Usually we have our own subcontractors for each work. One effective way of estimating an activity duration is to compute it. Compute it. Compute it by applying a crew or equipment production rate, as we discussed before in the previous video. So what is the production rate for a crew or a certain equipment? And you compute it by applying a crew production rate to the total number of units of work. Total number of units of work to be done. For example, you have your task, your activity is drive piles at abutment number one. Let's say a production rate for a pile driving machine is 4 linear meter per hour. For example, 4 linear meter per hour. This is if I would take a guess, it would be a sheet piling. So you have a 4 meter per hour. So you can drive sheet pile 4 meter per hour. Yeah, it's about that rate. So one sheet pile around like 400 mm, like a feet. So 4 meter per hour is about that duration. So let's say there's your rate 4 meter per hour. You can drive 4 meter per hour pile. So you need to drive for 20 meters. So this is what in the contract says, in the BQ says. So 20 meters per pile point, and there is 100 points. So you have 100 points of pile to be driven. So you have 100 points. So each points need to be driven 20 meters. So you have 200 meters. And 200 total of 200 meters to be driven divided by your rate here. So your rate, so you get 50 hours. So this is how you estimate. So if you are using hours and hours, if you're using days, you convert it to days. Like this is, I think, divided by 8 hours of work, it will be uh, 7 days, about 7 days. I think yes. So another approach in determining activity is to assume a crew size and use estimated labor unit cost using cost. This time you're using cost instead of productivity. So example, you have a cost that you estimate. Let's say maybe this is the actual cost. fuel cost per unit cubic yard. Let's say the cost for compacted backfill to be 8 8.45 8 ringgit 45 cents per cubic yard. So in the contract you have 470 cubic yards to be compacted and backfilled. Thus, to direct mathematics. Thus, each of these activities has direct labor cost of. So here you have 170 in the contract. So this is your cost per cubic yard. So you divide it, you multiply. So the total cost to complete 170 cubic yards of backfilling work is 1,436 ringgit. So assume, so the cost is here. So assume you want to use 3 laborers, which cost 20 ringgit per hour. So you have a 30 ringgit, 22 ringgit per hour. So you're working 8 hours a day. So you want to use 3 laborers. So your total cost of 3 laborers per day is 528 ringgit. So simple mathematics, you divided your total cost for the work based on the requirement of the contract. Excuse me. And then you divide that value to your cost of your planned rate and number of workers. It will be 3 days of work. So one way is to use the production rate, which is normally we use. Another one is to use your cost per cubic yard. Let's say this cost is quoted by your subcon, or this is the rate that you calculated based on the machineries or whatnot. So based on the cost, you come up with this, or based on the productivity rate, you come up with this. But it is wise to remember that for repetitive activities that let's say that piling activities is being repeated throughout the whole project, let's say 3 times, because a lot of section requires piling, for example. So repetitive activities may result in improvement in productivity. Improve in productivity lead to reduced duration. So you can reduce your activity duration should the activities be repeated many times throughout the project. So the first one will be a little bit longer than the subsequent repeated activities. It is, a logical base assumption for you to reduce duration of activities. Should there is a need to reduce the duration. And next, let's discuss about time contingency. So when the time estimate is made for activity, it is based on assumption that, as we said before, a normal condition. There's no bizarre weather, there's no worker strike. So concessions for abnormal, understanding on abnormal or random delays are accounted for in a number of ways. So the simplest being a contingency allowance. You allow for contingency, like we've discussed before, during monsoon season. So you make some allowance for contingency. So there will be days that you cannot work due to heavy storm or flooding. Where these occurrences can be recognized as activity specific, you can recognize this for activity specific, like I've mentioned before, excavation work cannot be executed during heavy rain, during raining season, so it's hard for them. So that is activity specific. So if it is can be recognized, so the contingency may be added in the form of uncertainty variance to the activity duration. You can add on the activity duration. It's a logical thing to do. So this concept is fundamental to the PERT method, especially in research for PERT method, for research and development. So this concept is fundamental because in research there should be contingency for any contamination to the sample, for example. So there will be a delay, so you need to repeat the test subject and so on. And also applicable to construction project, CPM method. So in most cases, though a contingency allowance cannot be applied to individual activities to account for general project delays, such as those caused by fires, accident, equipment breakdowns, labor problems, late material delivery, damage to material shipment, unanticipated site difficulties, and the like. So some contingency allowance cannot be applied to each activities, each individual specific activities, such as this highlighted here. So often it is impossible to predict which activities may be affected and by how much. So it's hard for you to estimate how long the rainy season, how much you'll be affected, how much delay that you need, how much extra days for you to need to provide for the affected activity. So as a result, general allowance for such time contingency normally is added to the overall project duration or at the end of specific construction sequence. Usually we add at the end of a construction sequence, at the end of specific, let's say at the end of a piling work, we add more days if we expect some contingency, or the overall project duration. Once you are finished the optimum number of days for the total project, so you add more days at the overall project duration, so that we can allow for that such contingency. So project weather delays. Project weather delay is probably the most common example of project delay. A great weather delays will affect type of project, a specific type of project usually, because for example, if you are doing the structural project like a superstructure, for example, if you are building a high-story building, high-rise building, so once you finish your substructure work, so weather will not affect won't have any effect on your works. Heavy rains won't affect you, so there will be no flooding or you need to pump out water because you already achieved a superstructure level, so you can proceed work without being affected by the project by the weather. But a certain project, for example, it listed here highway project. So highway cannot lay your crush run if there's a flooding, there's a heavy rain. You cannot lay your pavement during heavy rain. Also utilities project, let's say you have excavate, you lay pipe, pipe for you want to lay your cables for utilities, for internet cables, for example. So you need to stop your project if there is a heavy rain, because your your excavated pipeline will be flooded with water, so you need to rain for rain to stop, and the ponding water to subside, or you need to pump out the water. And last one is a third project, usually at the start. For example, at the start of the residential area project, so earthwork need to be carried first. So earthwork is heavily affected by weather. It is important to include probable delay due to weather in final project time, as we mentioned earlier. So in final project total duration, so you add more times just for the weather delays. For example, in Malaysia during the monsoon season at the end of the year. So should your project start at the end of the year, so you need to consider adding more times to your project time to make up for weather delays. On buildings and other works that can be protected from weather, allowances for time loss are commonly applied to those groups or activities susceptible to weather delays. For specific activities such as piling, substructure work, so that the sort of activities need to be considered as affected for weather delays. You need to add more days on that should you expect weather delays to occur. Weather delays will have higher impact on certain tasks, as I mentioned before, and seldom is a job of this type completely shut down due to weather and a standstill. Uh, Usually, unless it's very bizarre rain and heavy flooding, usually it won't cause your project to be ground too hot. It won't cause your project to stop. Uh, Such as war would cause your project to come to a complete stop. But whether it only cause delays, but still need to consider adding more duration to your activities. Next, we will take a look at network time computation. We will compute the time required to finish activity. So we will discuss it in the next video. Thank you.